Welcome back to the Forward Operations devlog series, where I pause development every 90 days to catalog my latest progress and challenges. This sprint I had only one goal, and that was to allow the player to split units into smaller units for greater tactical maneuvering. I expected this one item would take me the full 3 months, but it came together so quickly I was able to implement some quality of life features and polish up unit movement. I even got to spend some time digging into the math behind Splines. So for this episode, let's talk about what's new with commanding units, and also how my approach to systems in the past helped me out in the present. Hi there, I'm Jarrett, and this is my hobbyist game dev channel, Damage Algebra. Let's get into it. So let's start with the theme of this sprint, splitting units. Here's a quick demo. After the last devlog, we could click on a soldier and drag out a path for their fire team to follow, and that still works just fine. But what's new is that when you right-click on a soldier, one of the options should be to split the fire team. This doesn't change the organizational structure of the unit, it just means that the fire team can no longer be issued commands. Instead, when you click on a soldier and drag, the game will issue that command to the soldier's buddy team, not the whole fire team. Now I can move the two buddy teams independent of one another, which gives me a lot more tactical options for how I deploy my firepower. And of course, since you can split a unit, you should be able to reform the unit. This works the same way, just right-click on a soldier and select the reform option. Now I can once again issue a command to the entire fire team. Okay, so that's the end result, but what did it take to get there? Couple of things. First, I needed a way to know which units are split and which are not. Thanks to the composable data structure I've explained in previous devlogs, this was really easy. I just created a new data component to hold a Boolean value for whether or not the unit was split that I called splittable unit for now. Here we can see it on the fire team's entity, and as I split and reform the unit, the state shifts between true and false. Second, I needed some logic that uses the splittable unit data component to determine which unit is the controlling unit for the pawn. To do this, I added a very simple utility method to my unit service class. For me, a service class is just a utility or helper class representing a particular feature of the game, in this case, unit-based helpers. Each method answers a question about or makes specific changes to the things that you give it. In this case, the getControllingUnitForPawn method is looping through the units the pawn belongs to from the highest level to the lowest level, and returning the first unit that either doesn't have the splittable unit data component, meaning it can't be split, or has the component and is not marked as split. This gives us the highest level unit that pawn belongs to that we can issue commands to, or null if there are no matches. With this utility method, we can move on to the next task, which is giving the player a way to change the value in the splittable unit data component. Here again, I was able to take advantage of the existing command pop-up system that I built last year to let me order individual soldiers to do things like pick up items and eat food. The way it works is each possible command is its own scriptable object that implements 3 methods: isApplicable, getCommandLabel, and execute. For this command, the isApplicable method checks to see if the controlling unit has the splittable unit data component and if the isSplit value is exactly false. If the left side is null or true, then this unit cannot be split, or it's already split somehow, and this method would return false. Otherwise, it returns true, and the command would show up in the context menu as a button with the label that comes from, you guessed it, the getCommandLabel method. Finally, when the player clicks the button, the execute method runs, which just sets the isSplit value to true in the splittable unit data component. While we're talking about command pop-up objects, here's the opposite command that reforms the parent unit. It's a lot of the same things, but you'll notice this extra try-get-unit method. Since reforming means checking the parent of the unit that is controlling the pawn instead of the unit itself, this is just a bit of logic to grab that parent. You can see it's used in all 3 of the other methods. Now that we have our 2 commands, we can create scriptable objects for them and add them to the system's list of commands to check when an entity is right-clicked. Now, when we right-click on a pawn, we're given the option to either split their controlling unit or reform their parent unit, depending on which one is applicable. Alright, so now the player can split or reform units, but that doesn't actually mean anything as far as gameplay is concerned. When I built out the command line dragging mechanic last sprint, I hard-coded it to work with fire teams only, and it only supported drawing one line. That worked fine as an experiment, but now it needs to become more of a system that different entities can plug into. First things first, control of the line needed to be moved from the drag system to the unit. Originally, the drag system monitored user input, maintained a list of points as they were drawn, and updated a line renderer component that it controlled to draw the line in the game world. This is too much. The system doesn't need to control drawing the line, and it doesn't need to manage the line data either. It just needs to update the command chain on the unit and let the unit control its own line based on its own data. Doing this ensures that the system is generic and can work with any unit, and we can get a nice separation of concerns. So here in the controls drag system mono behavior, when a drag starts, we pause the game, get the controlling unit for the pawn, which can now be any kind of unit, and give it a brand new command chain. This removes the unit's old command chain and gives us a blank one to work with. Next, we add one link to the chain. I refer to the last link in the chain as a soft link, because this link represents where the cursor is as you drag. A hard link, conversely, is any of the command links before the soft link that represent markers along the path that don't move. So the final link in the chain is the soft link, and if the cursor moves a meter or more from the last hard link, then the soft link is converted to a hard link, and a new soft link is added to the end of the chain for the mouse to control. You can see this logic down here at the bottom of the recalculate line method in the drag system. When the dragging completes, the drag system stops moving the soft link, and that's where our line ends, right where your cursor was. On the unit side, we need to move over the logic that controls drawing the line in the game world. For this, I created the controls command chain line mono behavior and added it to all the unit game objects, like the fire team and the two buddy teams. I also had to add a line renderer for the new behavior to manage. Eventually, I expect the setup will get baked into a unit prefab, but for now I'm just setting it up manually. Not sure why I put the line renderer on its own child game object though, that's probably something I will redo later. Anyway, this behavior is pretty simple. I just use a coroutine that runs every fraction of a second to change the points on the line renderer, and then the line renderer does the work of drawing the line in the game world. Okay, so now we have a much better, more generic system that doesn't care what unit is controlling the pawn you have selected, it just changes the command chain data for that unit and lets the unit handle the rest. With all these pieces in place, we now have the ability to split and reform units, and the ability to issue commands to whatever unit is in control of the pawn we have selected. The only finishing touch left is to clean up previous commands when a unit gets split or reformed. There's already a manages unit command behavior given to units to monitor and react to changes to command chains and links, so I just added a listener for when the unit's isSplit value is changed, and null out any command chains in that unit and its children. And with that, this feature that I thought was going to take me forever was done pretty quickly, and I have to say I'm really happy with the systems-based approach that I've been taking so far. Thinking of each feature as a discrete set of functionality and what the interfaces are between the systems has allowed me to iterate much quicker than I expected, and I already expected it to be quicker. Being faster really worked in my favor this sprint because I knew I wouldn't have a lot of development time in May and June. That doesn't mean I didn't manage to sneak a few extra things into this sprint. So here's a short roundup of some of the quality of life improvements and tweaks that I made. First, did you notice how nice and smooth the lines are now? That's right, we've got a little spline action going on. If I'm being honest, this actually proved to be harder in a lot of respects than the unit splitting. I always wanted to write some basic spline logic and dig into the math though, and this was a nice chance. I know there's the Unity Splines package, and I even own a license for curvy splines, but just making the lines smoother seemed like something I could rig up myself pretty easily. As far as resources, I can't recommend Freya Olmer's videos on splines enough. They are straight up art as well as educational. When you're done here, go check them out. I also leaned pretty heavily on a video from Chris over at Llama Academy about smoothing line renderer paths. The secret sauce I was missing was finding where to place the control points, and I straight up stole his methodology. If you're not afraid of some math, here's the bulk of my Bezier curve implementation, including the interpolation formula there towards the bottom. And now the command lines are nice and smooth, and drawing long arcs is super satisfying. You may have noticed I also configured different line colors for different units, which also makes it much nicer to look at. Sticking with the line drawing, I found it annoying that if I messed up while drawing a path, I had to start all over. Editing the path is something I want to do eventually, but for now I just added the ability to walk the line back. This was another change that was tricky to get right, and it doesn't always work perfectly, but it's really nice to have. The basic idea is that if the soft point is within a meter of the second to last hard point, meaning it's between the second to last and the last hard point, we're probably moving backwards instead of forwards, and we can remove the last hard point. Finally, I spent a bunch of time improving the movement of the soldiers themselves. The biggest problem was that soldiers would occasionally get stuck and then end up in an infinite loop, making them unresponsive. This drove me crazy when I was testing, so I added this isStuck method to the movement action that checks to see if the soldier has been stuck in one place for a long time. If they have, then I cheat and mark that movement as complete, and I try to navigate to the next command link point. Now, I don't lose control of the fire team members because they get stuck, and going around complex terrain is much better. Speaking of navigating complex terrain, I wanted soldiers to be more cohesive as they squeezed around obstacles and gaps. It didn't make sense for one soldier to go around an obstacle by themselves and leave their team on the other side. Now, when a soldier hits an obstacle, it will test points between its assigned location and the leader's assigned location and try to find a spot that works closer to the leader. This has the effect of having the unit collapse together through narrow spaces and helps prevent individuals from wandering around obstacles alone. It might be a small thing, but it was bothering me, so I fixed it. Okay, last item, also about unit cohesion. I already implemented logic that would pause the unit if one of the pawns got too far behind. This made it look like the unit was waiting for the straggler, which is what a unit should do. But what about the straggler pawn? Rather than make the pawn complete all the command links between it and its buddies, I just mark all the intermediate points complete so they get skipped. Now, when the unit stops to wait, the pawn that fell behind will make a beeline straight to their teammates to rejoin them, instead of wandering off and completing extra steps. Again, it's a small thing, but it makes the pawns feel less dumb, and I like it. Alright, that's about it for this video. I hope you enjoyed it, and I hope you find the project interesting. Please feel free to comment below if you have any suggestions or questions. I'm always open to constructive feedback and new ideas. If you enjoyed the devlog, I'd appreciate a like. And if you're curious about the project's development, I'd love to have you as a subscriber here at Damage Algebra. Thank you much for watching. I'll catch you in the next one. Take care.